Hi everyone. We're going to change gears a little bit now. We're actually going to step away from trig functions after that deep dive into them, and we're going to spend some time on polynomial and rational functions with the specific goal here of really feeling ready for what we approach first in Calculus 1. So you will see a little bit of trig in Calculus 1, but it really is only a little bit, knowing your trig graphs and knowing some of the trig equation stuff and all your basic identities and special values. You'll see more complicated trig work in Calc 2 and beyond, and you'll have some different kinds of trig work you'll do in physics if you're taking that. But what you'll see more in Calculus 1 is some pretty messy algebra, a lot of function notation and function stuff early on. And you'll see more polynomial and rational functions, especially as you're starting off with some of the limit stuff. So we're going to focus on that a little, try and get some really good messy algebra in here that'll hopefully review some things you've seen before and add on this new layer of mess that you'll need for calculus. And we'll also include some function notation stuff. So this should feel like a good connection from your algebra and your pre-calc 1 stuff that you've done before. And I hope feels like a really smooth transition if you're headed to Calc 1 next. Okay, so let's jump in. This first example is about doing some complicated factoring. I say complicated because it looks scary. It's actually one of our simplest kind of factoring that we're focusing on here. We're going to work on factoring out a greatest common factor. And then we should always try and simplify and see if we can do more. But that's the big goal in all of these problems, is to identify a common factor and remove it from all of the terms. Okay, so first example, 20x to the 6th minus 12x to the 4th plus 4x cubed. We're looking for a common factor that we could remove from each of the 1, 2, 3 terms. Terms are separated by addition, subtraction. So I noticed just looking at the numerical part that 20, 12, and 4 are all divisible by 4. So I'm going to factor out a 4. And then the variable part is an x to the 6th, an x to the 4th, and an x cubed. So I want to think about that as 6 x's multiplied together in the first term. So 6 factors of x, 4 factors of x in the second term, and 3 factors of x in the last term, which means that we can factor out all 3 from the last term, but no more than that because we run out in that term, which means we can factor out all 3 x's from that last term, but no more than that because we've run out, and we'll have plenty to be able to do that from the other 3 terms. So, okay, remember factoring is a division. I know we've had to talk about that for some of our messy trig work, but it's good here as well. So we're looking at 20x to the 6th and we're dividing by 4x cubed. So 20 divided by 4 is going to leave me with 5. And then x to the 6th divided by x cubed. Sorry, I don't know why that jumped. Remember you subtract exponents, so that's going to leave me with x cubed. And then we have a minus. 12 divided by 4 is 3. And then if we take the x fourth divided by the x cubed, that leaves us with just 1x. Or you can just say it to yourself as I removed 3 of those 4 factors of x out. And then the last one, we've taken out everything. But again, thinking of this as division is really helpful because by taking out everything, I don't mean that there's a 0 left over. I mean there's a 1 left over. We divided 4x cubed out of 4x cubed, and that leaves me with a 1. And the number one best way to check yourself with these and make sure you're doing it correctly would just be to distribute this back through and make sure that you really do get what you started with. We're pretty good at distributing and figuring out the multiplication. It's less tricky than the division, so it's a really powerful check here. When you get here, always look at what's in the parentheses and see if you can do better. Sometimes you can combine some like terms. Sometimes you need to distribute a little bit and combine like terms. This time, I don't see anything that I can do. Once I get to this point, I'd be asking myself, could I factor it a little more maybe? But this is an x cubed and an x and a 1, so I don't think I'm going to get very far with that. I think I'm pretty good. But do give that a look. Don't just assume that you're done when you take out the common factor. Okay, so that really was polynomial work. The next two actually are not polynomial. I've mixed in a little bit of exponential stuff and then a little bit of radical stuff, the square root in the part C. So this is a little bit tricky looking, but it really is the same step. So kind of think about it just like when we did the trig identities and you practice factoring trig expressions instead of just regular quadratic expressions. This is an extension of that. And I just want you to see that you can do this with exponentials like e to the x or t to the 1/2 or all sorts of things. This part B is, I think, maybe a little extra tricky. That's why I put it on the example one. But I did want you to notice that just because it's an e to the x and an e to the 3x doesn't mean you're stuck. Some people will feel a little stuck with that. There's a couple of different ways to think about that. One is that e to the 3x is the same as e to the x cubed. If you have something with a power and you raise it to another power, you'd multiply, so that would become 3x. So I could absolutely factor an e to the x out of an e to the x cubed. Another way to think about it, exponent rules are great, is you could split it up this way. You could say an e to the x cubed is the same as an e to the x times an e to the 2x, because there the rule says you would add the two together. X plus 2x is 3x. And again, what I can see there is there's a factor of e to the x that I could remove from that. So either way you're thinking about it, what I want you to see there is that you can absolutely factor an e to the x out of that. My pen's being a little funny. If you're looking at it as the first one, I'd say, okay, well, factoring out is dividing it out. So we've canceled one of them and there'll be two left over. Or if you're looking at it the second way, you've canceled the e to the x, the e to the 2x is left over. Or you can even just leave it written as e to the 3x and say, okay, how do we do this? We subtract exponents and 3x minus x is 2x. So a lot of ways to think about that. There's a lot of exponent rules. But either way, you should get a 2x left over. And if that'll write, oh, sorry, I don't need any of the x. I got so worried about writing my x. There we go. So that is factored. And again, sometimes you can do something with what's left in the parentheses. I don't think you can here. And I'm not trying to say you need to try and factor everything that you see with an e to the x. I just want you to play around with this a little and have this kind of in the back of your head as a tool you can use when you're in calculus and get to some messy answers that you're trying to simplify or some messy equations that you're trying to solve. All right, same idea for C. That's not actually a polynomial. Polynomials have to have all positive integer powers on the variable. But you can use the same kind of trick. It might not be obvious what to try here. So I'm just going to show it to you and have you practice a couple. And again, the goal is just to have this in mind as a trick that you'll be able to use next quarter. So here, if you get something like this with a t to the 1/2 and a t to the 3/2, or maybe there's a t to the 5/2, or whatever it is with all these fractional powers, you can factor out of that still. Just remember that factoring is a division, and you want to take the smaller power just like before. So I'm going to take the t to the 1/2 out. And if you're dividing t to the 1/2 by t to the 1/2, you should be left with a 1. And then we'll have a minus, and we'll have this 4 left. And this, I think, is the trickiest part. We're taking a t to the 3/2, and we're dividing it by a t to the 1/2. And again, remember, the rule is you subtract exponents when you're dividing. So 3/2 minus 1/2 is 2/2. So that's just a t to the 1. And that's actually really nice. We do have the t to the 1/2 hanging out in front still, but what we're left with in the parentheses is linear. It's really simple. So say you're trying to solve an equation, that would be a great factor to work with for solving an equation. So this is a really cool trick in that it takes something that sometimes has even more than the two messy root or fractional exponent pieces in it, and it cleans it up a whole lot. So play around with that one a little bit. Last one, let's get back to the polynomials, since that is our big focus for this section. So here I'm seeing that I have two terms I'm going to show you right there. That's the split. Everything before that line is attached by multiplication, and everything after is as well. There is this little addition subtraction within the parentheses, but still the big operation here is the 5 gets multiplied by the x cubed, and that gets multiplied by the 2x plus 1. Same for the other one. So I'm looking for what's in front of the line and after the line that I drew that I could factor out. And I see that both have a -5. I also see that both have some x's, 3 x's in the first term and 2 in the second, so we can only take 2. We won't be able to take out more than that, but that'll be nice. And then look inside those parentheses. Sometimes you can entirely factor out what's in the parentheses. It works beautifully. You'll have one or two of those as you're working through the practice. So don't forget that that is an option. This time I didn't get it, so let's look at what's left over, and it will include the stuff in parentheses. From that first term, there was a single x that didn't come out, and then there's the 2x plus 1. And then after those parentheses, this is maybe a little tricky, since I factor out the negative sign as well, that's going to become a plus. The 5x squared is completely gone, but I do have the 3x minus 2. So here's one finally where I am going to work a little bit harder to clean up what's in those parentheses. So I'll leave the negative 5x squared out in front. In the parentheses, the big operation here is this addition. And what I'm seeing is that if I clean this up a little, it's really a quadratic in there, just kind of written in a weird way. I might be able to factor even more. So I'm going to get rid of both sets of parentheses. The first one, that means I have to distribute an x through. So I get 2x squared plus x, and then a 3x minus 2. I guess I'll just do a square bracket there. And I can combine some like terms in that. So I have the 2x squared, and then I end up with 4x minus 2. And I like that. What I'm seeing in the brackets now is I can actually factor out another 2. I actually have another greatest common factor that wasn't real obvious until I did some simplification. So when you factor that out to the front, it'll become 2 times negative 5x squared. I'm just going to go ahead and multiply that so I don't mix myself up and say that's a negative 10x squared. What I worry about is sometimes people will do this 2 times negative 5x squared. That dot in between will kind of get lost, and they'll mix themselves up even a little bit and think it's 2 minus 5x squared. So that's the kind of step that I actually think it's better sometimes to do in your head. And that leaves me with an x squared plus 2x minus 1. And that's really close. I was actually thinking for a second I was going to get something factorable. If that was a plus 1, it would factor really nicely. But with a minus 1 on that, I don't think there's anything that I can do with that. So I think I got stuck again, but do watch for it. I think you might have at least one on your homework where you do end up with something in those brackets that you can factor a little further. Okay, so that's messy looking factoring. I would say, no, actually, I'll save that for the next video.